Proceeding with first question. In this question, what we have been given is, let alpha, beta be real numbers, right? Alpha is given to be 0 to pi by 4 and beta is given to be minus pi by 4 to 0. So here alpha plus beta will be minus pi by 4 to plus pi by 4. Now here if I am considering this part, right? In this what I have to analyze is, I have to combine those terms which can create some formula of trigonometry, that is sum or difference formula. So I can clearly see these two terms can be combined. This will form sin alpha sin beta plus cos alpha cos beta. So let's solve it here. This will be of the form sin alpha sin beta plus cos alpha cos beta divided by sin beta cos beta, right? Plus these two terms will be combined, second and fourth term. This will make it cos alpha cos beta plus sin alpha sin beta whole divided by sin alpha cos alpha. This term whole square, right? Now in this, in the numerator we are getting cos alpha minus beta for both the terms. We can take it common outside and that is given to be 2 by 3. So 2 by 3 square, that will be 4 by 9 outside, right? In the numerator we have 1 here. So this is 1 by sin beta cos beta. We can convert this into double angle, right? That is sin to beta by multiplying by 2 and dividing by 2. So 2 by sin to beta plus. Similarly, this is sin to alpha whole square. 2 also can be taken common. 2 square will be outside. So 2 square, that is 4 into 4, 16 by 9. Now on taking LCM, this will be sin to alpha plus sin to beta in the numerator. Sin to alpha plus sin to beta will be 2 sin c plus d by 2, that is sin alpha plus beta into cos alpha minus beta whole divided by sin to alpha into sin to beta. Again we can multiply by 2 and divide by 2, right? So if I multiply this by 2, this will be 2 square, and in the denominator 2 sin to alpha 2 sin into sin to beta will be sin, this will become the formula of cos a minus b minus cos a plus b. So that's why what I am writing here is cos a minus b, that will be twice of alpha minus beta, minus cos twice of alpha plus beta. So from numerator you can see these values in the numerator we have been given in the question, right? Denominator we have to solve out. Let's consider these values first of all. If I put these values, what will be here? This is coming out to be 16 by 9. Let's take it on the next slide only. This is 16 by 9 into 4, that is, this 4 will also be coming outside, right? 4 square, that is 16. So I am writing 16 by 9 into 16. This will be 16 by 9 into 16, and we have two terms in the numerator. Those are sin alpha plus beta and cos alpha minus beta whole square. So these two values multiplied, 2 by 3, 1 by 3, that is 2 by 9 whole square will be, let's write it outside only, 2 by 9 whole square. That is 4 by 81, right? Now inside value is 1 upon cos twice alpha minus beta, right? Cos twice alpha minus beta can be converted. It is a double angle of cos. Cos to theta is 2 cos square theta minus 1 and also 1 minus 2 sin square theta. So alpha minus beta is with respect to cos angle. We can convert into cos 1, that is 2 cos square theta minus 1, and for this one we have sin value, right? For alpha plus beta we have sin value, that's why we will convert this into 1 minus 2 sin square alpha plus beta. So converting these values, in the denominator what we have, this is 1 upon 2 cos square alpha minus beta minus 1 and minus 1 minus 2 sin square alpha plus beta. Right. Both the values have been given, whole square is required, right? In the numerator we have taken all the values outside, right, which are denoted here only. Now according to this what we are getting is, let's keep it as it is. Now inside is 2 cos square cos alpha minus beta, right? This value is 2 by 3. Cos alpha minus beta is 2 by 3. So 2 by 3 square, that will be 4 by 9. 4 into 2, that is 8 by 9. 8 by 9 minus 1. And this is minus 1 and plus, this will be 2 into sin alpha plus beta, that is 1 by 3. 1 by 3 square, 1 by 9. So this is 2 by 9. This whole square coming out to be, see, on taking LCM, this will be 8 plus 2, 10, 10 minus 18, that is minus 8 by 9. So this will be 9 by 8 in the numerator. So 9 by 8 whole square right? So 64 can be cancelled out, that is 16 into 4, and 81 can be cancelled out, this is 16 by 9. This was your y square, and it has been asking you about the greatest integer value, that is integral part of this, which will be integral part of 16 by 9, right? So obviously this 16 by 9 is 1 point something, so its value will be 1 only. That is your final answer. Proceeding to next question. Next is, if yx is the solution of the differential equation, this is the differential equation, right? Now, slope of curve is never 0, then the value we have to find out, right? y1 is given to be 2. So according to this equation, what I can write is x dy is equal to y square minus 4y dx, sorry. Separating the variables, this will be y square minus 4 dy, sorry, this was not dy, 4y. Y square minus 4y is equal to dx upon x. On integrating both the sides, this will give you, right, see in this manner, what you have to understand here is, we can directly convert this part into factors, right? We can apply the factor here, that is y into y minus 4. So if I convert these factors, what this will become? 1 upon y minus 4 minus 1 upon y, this will be giving me y minus y plus 4. So in the numerator, I have 4 extra, so I have to divide by 4, right? So this part has to be integrated, right? This entire part is to be integrated, and on the right hand side, this has to be integrated. So clearly, 1 upon y minus 4, that is ln y minus 4, ln mod y minus 4 minus ln mod y is equal to ln mod x plus, let's consider ln c only. So this 1 by 4 is present here. Let's multiply on the right hand side only. So according to this, this will be 4, and 4 multiplied with this will be another constant. You can consider it again to be c only. Now here this can be divided. This will be ln mod y minus 4 divided by mod y is equal to c x power 4. Right? X is positive, that is given in the question also, and x power 4 will definitely be positive. So considering this is directly, sorry, this was, both sides ln was there, so we are eliminating ln from both the sides, right? Now considering with respect to mod values, what this will be? Mod y minus 4, right? Mod y minus 4 is c x power 4 into mod y. So first of all, if I consider with respect to this given value, that is y1 is 2, right? So what will be value of c from here? y1 is given to be 2, that is 2 minus 4, this will be equal to c x power 4, that is 1 only, and into y, that is 2. So clearly, equation what we are getting is the value of c is 1 only, right? If c is 1, then y minus 4 is equal to c is 1, and this will be x power 4 into mod y, right? Okay, let's consider first of all the positive part, right? If I take the first case, that is y minus 4 equals x power 4y. So from here, what will be my y? That is 4 upon 1 minus x power 4, right? And second case will be, now whether this will be valid or not, let's check it out as per the original given equation, right? Y of 1 is 2. If x is 1, then y is 2. So if I place x1 here, y is not defined. So x1 gives me y as not defined, that's why this is not applicable. So I have taken y positive, mod y is positive, so let's take another sign, that is minus x power 4y, right? Mod opened with a negative sign, this will be giving me y as 4 upon 1 plus x power 4. So here if I put x equals 1, I will be getting 4 by 2, that is 2 only. So this is correct. According to this, this is rejected, right? This part is rejected. Now 10 times y root 2, obviously we have to place the value here, y root 2, what this value will be? Simply by considering the part of 10 times, y of root 2 will be 4 upon 1 plus, root 2 power 4 will be 4 only, 1 plus 4, that is 5, 10 4 by 5, that is 8. This is your final answer. Proceeding with next question. Next we have greatest integer less than or equal to, right? Okay, first thing to be observed here is these both are interrelated. How they are interrelated? Let's see. If I take this entire part to be y, you can see this is 2 power y minus 1. What will be x from there? That will be this only. Right? It is of the form 2 power x minus 1 and whole power 1 by 3. So clearly it is the inverse function of this one. Right? What I am saying is, if I take this y as x cube y to be y equals log x cube plus 1 base 2. Right? So from here, what will be the value of x if I find the inverse function of this one? Right? It will be this one. How? Let's interchange this x and y cube plus 1 base 2. So from here, what we are getting is 2 power x equals y cube plus 1. Right? Or I can say y cube is 2 power x minus 1. Or I can say y is 2 power x minus 1 whole power 1 by 3. Right? So clearly, inverse function of this one is 2 power x minus 1 by 3, which is this one only. And here you can directly apply the property, that is integral a to b fx plus f inverse x is equal to directly bfb minus af. So clearly we can apply this property as f inverse x integral is also x dash fx, x f dash x, whole integral will be x fx only. It is the interrelated property, right? You can directly follow this method also. So BFB, B limit of fx only, that is 2, f of b will be, placing here the value 2, that will be 8 plus 1, 9, log 9 base 2, minus a is 1, 1 into log 1 plus 1, that is log 2 base 2, which will be 1 only, so minus 1. So again you have to find the greatest integer less than or equal to. So clearly greatest integer part of this one will be, you have to find the greatest integer part of this, which will be equal to, as log 9 base 2 is approximately what? This is 3 only, 3 point something. 3 point something into 2 will be 6 point something, 6 point something minus 1 will be 5 point something. So clearly it is closer to 8, right? 9 is closer to 8 and 2 power 4 will be 16. So it is lying between 8 and 16, but closer to 8. That's why it will be decimally very less. So clearly that will give you 5 as the answer. Okay, proceeding with next question. Next what we have is easy question. What you have to do, you simply have to take log x base 5 equals t, right? X will be 5 power t. So writing this as 5 power t, 16 t cube minus 68 t. This is equals 5 power minus 16. So this will be t into, comparing both the powers, t into 16 t cube minus 68 t is equal to minus 16, right? Let's take 4 common from this one, right? 4 common can be taken from both the sides. Let's cancel it out. So this will be 4t square, right? 4 taken common, 4t cube minus 17t, and this is minus 16. So this comes out to be 4t power 4 minus 17t square plus 16 equals 0, right? Now here what we can see is, okay, on taking 4 common, this will also be minus 4 only, right? This is not minus 16 now, this is minus 4, and this will be plus 4. So from here we can easily factorize. You can see 4t4 minus 16t square minus t square plus 4 equals 0. So what we are getting is 4t square. T square is coming out to be either 4 or 1 by 4, right? T square is coming out to be 4 or 1 by 4. According to this, what we can say is t is coming out to be plus minus 2 or plus minus half, right? And t is your log x base 5, which is plus minus 2 or plus minus half. So from here x will be 5 power plus 2 will be 25, 5 power minus 2, 1 by 25, 5 power plus 1 by 2, that is root 5, 5 power minus 1 by 2, that is 1 by root 5. So we have been asked product of all positive real values. So product of all these will be 1 only. Product of all the values will be 1. Easy question. Proceeding with next question. Next is, this is directly based on the approximation. Binomial expansion, you can apply the expansion there, right, in all 3 of them. So according to this, if I apply the expansion, what will be the value of beta? This will be limit extending 0. E power x cube is simply 1 plus x cube No need to go beyond x cube. This is x cube only in the denominator, right? If I multiply by x square and divide by x square, sin x by x limit extending 0 will be 1 only. So highest degree is 3 in the denominator. So I want up till 3 only, no further weak is adjusted here. So no other value you have to write as per the expansion. Only 2 values are enough because in the denominator we have highest degree 3. So again in this part you can apply the same thing. This will be 1 minus x cube by 3. Same goes with this part also. This is entirely multiplied with sin x. So 1 minus x square by 2. Right? Power is multiplied, that is simply 1 plus n x. N is multiplied inside. Minus 1 into sin x. This one gets cancelled out, and in the denominator what we have, let's separate this out. This has x sin square x, x sin square x. So one of the sin x gets cancelled out, right? Here what you have to do, sin square x multiplied by x square and divided by x square. So x cube here, this will be 1, right? This limit is 1. Same goes with this one, divide by x, multiply by x, this limit is 1. So now what you have to find is, you just have to take this entire part limit, right? According to this, what we are left with here is 1 is also cancelled out, right? X cube plus x cube by 3, that is 4 by 3 x cube, divided by x cube, that is 4 by 3. And from here this will be minus 1 by 2 only. X square gets directly cancelled out. So minus 1 by 2. This is 8 minus 3, 5 by 6, and you have to find 6 beta. So 6 beta will be 5 only. Proceeding with next question. Next is matrix question. See, all chapters are covered very efficiently, right? All diversity is well planned. See, in this matrix question, what you have to analyze is, this is given to be a singular matrix, right? That means its determinant is 0. So if I consider, let's take the factors of this. Okay, we can clearly see a power 5 can be taken common from all the terms. A power 5 common, this will be a square minus beta minus 1 into a minus beta, right? So if I take determinant, this term is equal to 0, right? So from here what I can analyze is, again, further factors can be done inside. A square minus beta a square minus beta a plus a minus beta. Now when you have to combine along with the matrix part, we have to utilize beta I, right? Beta is a constant, we have to utilize beta I. So determinant a power 5 multiplied with, this will give me factor as a into a minus beta, and this will give me 1. So clearly that 1 has to be written as I only, a plus identity matrix, and the another factor is obviously a minus beta, which has to be written as a minus beta I. So clearly in this, we know that we can find all the values, right? We can find individually. So first of all, if I consider the determinant of A only, what is determinant of A? Whether it is 0 or not, let's check it out. So if determinant A, beta into this minus this will be 0. This will also be 0. According to 1, this will be 2 minus 3, that is minus 1. So determinant is coming out to be minus 1. This determinant cannot be 0, right? Writing it individually. So this is non-zero, right? Now focusing on A plus I, what will be A plus I? A plus I matrix will be adding 1, 1, 1 in the diagonal. That will be your identity matrix. Beta 0, 1, 2, 1 plus 1, 2, minus 2, 3, 1, minus 2 plus 1, minus 1. So this is the matrix, right? A plus I. Now according to this, what you have to analyze is whether its determinant is 0 or not, or we are getting any value from that. So what will be determinant here? This will be beta plus 1, minus 2 plus 2. Beta is gone from here, 0 again. This will be 2 minus 6, that is minus 4. Determinant A plus I is coming out to be minus 4. So this is also non-zero, then clearly this has to be 0, A minus beta I, right? A minus beta I will be, what will be A minus beta I? Let's write it here. A minus beta I. So according to this, if I have to take the, let's first of all write the matrix only. A minus beta I will be This beta will be cancelled out, that is 0 only. Here 0, 1, right, 2. Here it will be 1 minus beta, right. Similarly, here it will be minus 2 minus beta. In the first term, it was beta minus beta, that is 0. So this is the matrix, right. Now this must be, its determinant must be 0, right, because these two are non-zero. And you remember Cayley-Hamilton theorem, if you remember that, this is the characteristic equation for any singular matrix. Clearly you can see, not singular, for any matrix that is given by A minus lambda A equal to 0. So in this, determinant of A minus beta I will be, these two are 0 only, it will be expanded through 1 only, which gives me 2, let's write here, determinant of A minus beta I. This is 2 minus 3 into 1 minus beta. Right, this has to be 0. So according to this, 2 minus 3 plus 3 beta is equal to 0, or beta is 1 by 3. If beta is 1 by 3, we have to find 9 beta, that is 3 only. 9 by 3, that is 3. Proceeding with next question. This question is based on the coordinate geometry. This is with respect to the hyperbola. So as per the equation, you can directly see A is 10 and B is given to be 8. Now, very sincerely, first of all, analyze what has been given in these lines. Foci at S and S1, right, where S lies on the positive x-axis. Let's draw a rough figure here. We have a neat diagram on the next slide. But before that, let's consider roughly here. S and S1 are given to us, right? S lies on the positive x-axis, P be a point on the hyperbola in the first quadrant. Let SP S1 be alpha. P in the first quadrant, this angle is given to be alpha. This is alpha. Now, alpha is less than pi by 2, the straight line passing through S and having same slope as that of the tangent to P at hyperbola to hyperbola. So, tangent to P and line through S, that is parallel to this tangent, right? These two lines are parallel to each other. Intersects the straight line S1P at P1, right? S1P is extended and this line is intersecting at point P1. Now, let delta be the distance of point P from straight line SP1, that is distance, this one, distance of P from SP1. This is given to be delta, and S1P is given to be beta. This distance is given to be beta. Then the greatest integer less than or equal to this value, right? Here you can see beta and delta multiplied with sin alpha by 2. So we have to create such thing. Now, first of all, these two lines are parallel, right? These two lines are parallel. So what you have to consider is, we can apply first of all, if you remember the reflection property, that any tangent at any point to the hyperbola is angle bisector of the focal distances of that coordinate, right? Of that particular point, S1P and SP are being bisected by this tangent. So these two angles will be equal, right? These both are alpha by 2. And if this is alpha by 2, this angle is alpha by 2, these two lines are parallel. So this is your alternate angle. As you can see, this becomes your alternate angle. This one is also alpha by 2, right? This will be alpha by 2. Let's see the neat diagram and proceed with the question from here. As per this diagram, what we know, the information that we already know is x square by 100 minus y square by 64 is 1, right? Let's first of all find the eccentricity. Eccentricity is 1 plus a square by b square, that is 64 by 100. Root 164 by 100, that is 4 into root 41, that is 2 root 41 by 10, or you can say root 41 by 5. So coordinate of focus will be AE comma 0, A is 10, 10 into root 45, 1 by 5, that is 2 root 41 comma 0. Now, according to this, similarly, this will be minus 2 root 41, right, comma 0. That's why distance between these two focus is 4 root 41. So first of all, let's consider, we have seen sin alpha by 2, that is being asked. So let's write sin alpha by 2 from here. Sin alpha by 2 will be perpendicular upon hypotenuse, that is delta by SP. Delta by SP is by sin alpha by 2. Now, if I want to write SP, that is delta by sin alpha by 2, right? And one equation we already know, that is from the definition of hyperbola, difference between focal distances is equal to constant, that is 2a. So beta minus SP, right? Beta is S1p minus SP, this is 20. Okay, SP is delta by sine alpha by 2. This is 20. Okay, we have seen beta delta sine alpha by 2. Let's create this by squaring this up, in which we will get the term 2 beta delta by sine alpha by 2. So beta square plus delta by, this is again SP square I can write here. Okay, let's take the minus 2ab term on the right hand side. This will be 400 plus 2 beta delta by sine alpha by 2, right? Okay. Now I require this value, right? I require this value, then I can easily proceed with this part. So how I can create this part? Any other equation required here? So what equation can be applied? As we have written here, for root 41, that is the entire distance. So in the triangle SPS1, what we can apply is, we can apply the cosine formula. So cosine formula gives me cos alpha, this entire angle alpha between SPS1. Cos alpha will be SP square plus beta square only, right? Minus this square, that will be 16 into 41. So 16 into 40 will be 640 plus 16, that will be 656. 656 all divided by twice of, this will be beta into SP, where SP is again delta by sine alpha by 2. Okay. So from here, you can directly see beta square plus SP square, this value can be compared with this one, right? So according to this, what I can write is, let's call this T, this is also T. Now according to this part will be 2T cos alpha plus 656. This is 2T cos alpha plus 656, right? That is the value of beta square plus SP square. This is equal to 400 plus 2T, right? So this is 2T. Let's take this on the right hand side. This will be 2T, 1 minus cos alpha. And on this side, 656 minus 400, that is 256. Or cancelling with 2, this is 128, right? Now T into 1 minus cos alpha. What is T? T is this one only, that is beta delta by sine alpha by 2. 1 minus cos alpha again converted into sine only, that is 2 sine square alpha by 2. 2 sine square alpha by 2, this is equal to 128. So from here 2 cancelled out, this is 64. 1 of the sine alpha by 2 cancelled out. Beta delta sine alpha by 2 is coming out to be 64, right? Beta delta sine alpha by 2 is coming out to be 64 divided by 9. We have to find greatest integer. So 64 by 9, this will be, we have to find this value, greatest integer part of 64 by 9. So 9, 7, 63, that is 7 point something. So this will be 7. That is your final answer. Proceeding with next question. Next is, consider the functions, right? Two functions are given, fx and gx. You have to find the value of 9 alpha, right? Alpha is the area of region bounded according to these conditions, mod x less equal 3 by 4, y 0 to minimum of fx and gx. Which will be minimum? According to that, we have to apply the formula and find the area. So now first of all, let's consider by defining gx as it is 0 elsewhere, but we have to just consider inside mod x less than 3 by 4. So this will be, gx is coming out to be twice. If I take it to be positive side, that is x 0 to 3 by 4. Okay, let's first take the negative side, that is minus 3 by 4 to 0, right? Minus 3 by 4 to 0. If I consider this part, both included values, minus 3 by 4 to 0, the mod x will be opened up with a negative sign. So this will be twice 1 plus 4x by 3, right? And if I take this to be 0 to 3 by 4, this will be twice of 1 minus 4x by 3, right? And elsewhere it is 0 only. Mod x greater than 3 by 4 is 0 elsewhere. This is how gx is defined more clearly. Now, in this you have to simply draw these two lines, right? These two lines, which can be easily drawn, right? What is this line? This is obviously giving you 2 plus 8x by 3, right? According to that, we can apply the straight lines. We can directly draw the straight lines. How these straight lines will be drawn? as you can see, if I consider the straight line 2 plus 8x by 3, right? Let's consider some equation y equals 2 into 2 plus, okay, let's multiply here only 2, 3 plus 4x by 3, right? So this is the equation 3y is equal to 6 plus 8x, right, which is given by 8x minus 3y plus 6 equals 0. Similarly, one other line will be there, which is given by, let's write the 1 minus 4x by 3. What this will be? 3y equals 3 to this will be 6 and minus 8x. 8x plus 3y equals 6. Right, from both the equations you can see if x is 0, so two coordinates I can directly say x0, y2, right? x0, y2. This will be satisfying, so this you have to consider, right? Similarly, you can check for y0. For y0, this will be y0, what will be x? y0, x will be minus 3 by 4. So you have to draw the lines. This is not required to be written, but yes, definitely you have to solve it orally and you have to draw the lines. y0, x 3 by 4. So what we are getting is, these are the coordinates, right? x0, comma 2, one is the coordinate 0, comma 2, where both the lines are intersecting. Let's draw it here. Both the lines are intersecting with respect to the curve. One is a value 3 by 4, comma 0, right? And one is minus 3 by 4, comma 0, and one is 0, comma 2. So we have to consider also x between minus 3 by 4 and plus 3 by 4, right? These are the coordinates. Minus 3 by 4, comma 0 and plus 3 by 4, comma 0 and 0, comma 2. So 0, comma 2 is their intersection point. This is the straight line and this is the straight line. We require this part only of these straight lines, right? Now proceeding with next, what we have is this part. Fx is x square plus 5 by 12. So proceeding with this part, this is a parabola, upside parabola, right? X square plus 5 by 12. So 5 by 12 is obviously smaller than 2. This coordinate will be 0, comma 5 by 12. Now let's find this coordinate, right? We have to find this area. We have to find this area. Now, obviously, as it is symmetric, both the curves are symmetric to both the sides, to y-axis, then definitely we can find one of the areas and double it up. So considering area of this one to be, let's call it A1, right? This one will also be A1, so we have to find 2A1. First of all, let's find A1 only. What will be A1? First of all, let's take the intersection. This line was, what was this line? That is line with the negative slope. Line with the negative slope. This one, right? That is 8x plus 3y equals 6. This is 8x plus 3y equals 6. And, or you can directly take intersection with this part only, right? Line with negative slope is this one only, minus 4 by 3, you can see. This line, and you have to take intersection with this part. So directly writing x square plus 5 by 12, not writing this equation, directly writing x square plus 5 by 12. X square plus 5 by 12 equals twice of 1 minus 4x by 3. Twice of 1 minus 4x by 3. On taking LCM, this will be 12x square plus 5 by 12, that is 2. 3 minus 4x by 3, 3, 4, 12. So this comes out to be 12x square plus 5 equals 4 to 8 into 3 minus 4x, which will be 24 minus 32x. So this equation comes out to be 12x square plus 32x and minus 19 equals 0. Right. So here you have to factorize it, right? 19 cannot be factorized further, 12 can be factorized. Obviously, it will be 19 into 2, that is 38, 38 minus 6, right? Only one factor possible. This is 38x minus 6, x minus 19. Taking common 2x here, this will be 6x plus 90 minus 1, 6x plus 90. X is coming out to be minus 19 by 6 or 1 by 2. So we are taking intersection of this parabola along with this line, right? So obviously negative x is not possible here, right? So x is plus 1 by 2. If x is 1 by 2, what will be y? Y is this only, right? So y is coming out to be half square, that will be 1 by 4 plus 5 by 12, right? 5, this will be 3 plus 5, 8 by 12, or you can write by cancelling with 4, that is 2 by 3. So coordinate is 1 by 2, comma 2 by 3. This coordinate is 1 by 2, comma 2 by 3. Now you can easily apply the integration to find the area of this region, right, of this region. This is required here. Remaining, dropping a perpendicular here, this can be taken as a triangle, right? This area can be taken as a triangle. So that area will be directly with respect to the formula half into base into altitude. So area under this curve, right, will be integral curve that is given by x square plus 5 by 12, right, into dx. This is my area from x, what x is varying from 0 to 1 by 2, right. So this is required, right, 1 by 2 is required, that's why we have solved it up. So we have to limit this where up till where we have to find the area. So remaining will be found by half into base into height. So base will be 3 by 4 minus 1 by 2, 3 by 4 minus 1 by 2, into height will be 2 by 3. So this will be 2 by 3. So according to this, you can see on integrating, this will be x cube by 3 plus 5x by 12, right. We have to place this limit 0, 1 by 2. And this is 2 cancelled out. On taking LCM, this will be 3 minus 2, 1 by 4. So that is 1 by 12. On placing the value here, half, this will be 1 by 8, that is 1 by 24. And half again here, that will be 5 by 24, right. And we have 1 by 12. Okay, let's write this also as 2 by 24. So this is 8 by 24, that is 1 by 3. 1 by 3, that is A1. So final area will be double of this one. So final area will be 2 by 3. The total area will be 2 by 3, right. If we are considering alpha, so alpha will be double of this, that will be 2 by 3. And what we have to find out, we have to find 9 alpha. 9 alpha will be 9 into 2 by 3, that is 6, right. That is your final answer.
Hello students, let's have a look at question number 9. Question says PQRS be a quadrilateral in a plane where QR is equal to 1. So we have drawn here a PQRS quadrilateral whose length QR is 1. Then PQR and QRS angles are 70 degree. So this PQR, this angle total, and definitely QRS means this angle is also total 70 degree. So both the angles are 70 degree. PQS is 15 degree. So this angle we have taken 15 degree. So definitely this remaining angle will be 55 degree. Okay. PRS is 40 degree. So this P, then R and this, yes, this angle is 40 degree they are saying. Okay. So definitely we can say here that as this angle is 55 degree, this SQR angle is 55 degree and this total angle R is 70 degree. So this 55 plus 70 I will get 125 degrees. So definitely this remaining angle here I would say 55 degree. So if you just look at this triangle RSQ, so this Q angle in this triangle RSQ is 55 degree and this angle S is also 55 degree. So means triangle RSQ is isosceles triangle. So I can definitely say that this length RQ should be equal to this SR. Therefore here this length will also get 1. Now what we will do, in a triangle PRS, so I will write here, in triangle PRS, if we apply a sine rule, we will get this 1 divided by sine theta, 1 divided by sine theta, that side 1 and opposite to it we have angle theta. So 1 divided by sine theta will be definitely equal to this beta divided by sine 40, beta by sine 40. Cross multiplying we will get beta sine theta is equal to sine of 40 degree. So this is the one equation we got from the triangle PRS. In a similar fashion, if you just look at this triangle PQR, in triangle PQR, again if you apply sine rule, you may get this 1, that is QR divided by sine of 80. So 1 by sine of 80 must be equal to this side alpha divided by sine of opposite angle 70. So alpha divided by sine of, so opposite angle here is definitely this 30 degree, right. So this angle is 30 we got, because this angle is 40, therefore this total angle 70, upper angle is 40, so this lower angle will be 30 degree. So this angle is 30 degree, definitely that angle R in a triangle PQR will be 30 degree. So, I will get here sine of 30 degree. So, this sine of 30 degree is 1 by 2. So, I will get value of 2 alpha as 1 divided by sine of 80 degree. So, this is the second equation we got. Now, if you multiply these two equations 1 and 2, we will get 2 alpha beta sine of theta. Actually, we want to calculate what is the value of 4 alpha beta sine of theta, and after multiplying these two equations, we are getting 2 alpha beta sine of theta, which will be equal to definitely sine 40 by this sine 80. So, sine 40 divided by sine 80 I am going to get. Again, this sine 80 can be reduced as 2 sine of 40 and cos of 40, and we have here in a numerator sine of 40. So, this sine 40 get cancelled. So, this 2 if I take on the left side, I will get here 4 alpha beta sine of theta, and this is what we are interested in, and on the right side we just remain with what? This cos 40 in a denominator means sec 40. As we know that this sec 40 always lies between sec 45 and sec of 30. So, definitely this 4 alpha beta sin theta will also lie between those two values, but sec 45 we know we get root 2 and sec 30 we know 2 by root 3. So, our 4 alpha beta sin theta value will lie between 2 by root 3 to root 2. Come back and see, the question is asking in what interval this value may lie. So, definitely that value of 4 alpha beta sin theta is lying between 2 by root 3 to root 2, means it is lesser than root 2. So, definitely these are the two options where that value may lie. So, question was 4 alpha beta sin theta is contained in what interval? So, A and B are only two options where it will be contained. Well, now let us have a look at this question number 10. Question number 10 is saying that alpha is actually summation of k equal to 1 to infinite sine of pi by 6 raised to 2k. So, alpha is something like this, and g is a function defined from 0 to 1 to real values. The maximum value of g of x is to be function defined by g of x equal to 2 raised to alpha x plus 2 raised to alpha into 1 minus x. Then which of the following statements are true is the question. So, the minimum value of g of x is 2 raised to 7 by 6, B option is the maximum value of g of x is 1 plus 2 raised to 1 by 3, C option is the function g of x attains its maximum at more than 1 point, D option says the function g of x attains its minimum at more than 1 point. So, let us see how to solve this. Very first, let us calculate what the value of alpha is. So, as alpha here is sine of pi by 6, basically that will be 1 by 2, sine of pi by 6 is 1 by 2 and raised to 2k we have here, and k value is changing from 1 to infinite. So, this is nothing but 1 by 2 raised to 2 plus 1 by 2 raised to 4 and so on. So, this is a geometric progression, and definitely some of the infinite terms of the geometric progression we can calculate easily using a formula first term divided by 1 minus common ratio. The first term here is 1 by 2 square, that is 1 by 4, and for this GP, in fact it is infinite GP, common ratio is also 1 by 4. So, it will converge, and sum of all these terms will get something like this, 1 by 4 divided by 1 minus 1 by 4, and that will be definitely 1 divided by 3. So, the alpha value we got here. So, as we got the alpha value, we can easily get g of x function. So, let us see what g of x function is given. G of x given is 2 raised to alpha x, so it will become 2 raised to 1 by 3x plus what? 2 raised to alpha into 1 minus x means 2 raised to 1 by 3 into 1 minus x. So, this is our g of x we got, and this function is defined from x belonging to where 0 to 1, and we need to check what is its minimum value, maximum value, that is what they are asking. To check its minima or maxima, definitely we need to differentiate. So, let us differentiate this. After differentiating, what we get? G dash of x will get derivative of 2 raised to 1 by 3 will be 1 by 3, 2 raised to 1 by 3 x ln of 2, and here derivative I will get 1 by 3 again ln of 2 and 2 raised to 1 by 3 into 1 minus x. So, this is what I will get derivative, but for maxima or minima we take g dash of x equal to 0. Solving this g dash of x equal to 0, because this 1 by 3 and ln of 2 are common, means these two terms 2 raised to 1 by 3x and this 2 raised to 1 by 3 into 1 minus x should be equal, means their power should be equal because bases are already equal. So, we will get 1 by 3x is equal to 1 by 3 1 minus x. Solving I will get x equal to 1 by 2. So, at x equal to 1 by 2, definitely a function will have maxima or minima. How can we identify whether it is maxima or minima? We can whether check second order derivative, or definitely if you just check derivative at 1 by 2 plus, you will come to know that this term will decrease and this will increase, means on the right of 1 by 2 we are getting derivative as positive, and f dash of 1 by 2 minus means derivative when x value is little less than 1 by 2, means definitely this value will be lesser because x we are decreasing, and as x is lesser then this value will increase, means definitely now we will get derivative as negative, because the term which is in a minus sign is increasing and this term which is in a positive sign is decreasing, therefore we will get negative. So, definitely on the left of 1 by 2 we are getting derivative negative, means curve is going down, and then on the right of 1 by 2 curve is going up. So, definitely x equal to 1 by 2 is a point of minima, and so minimum value will get how much? G of 1 by 2 will be the minimum value, and that minimum value we can calculate by putting x equal to 1 by 2 here. So, I will get here 2 raised to 1 by 6, and this term will also go 2 raised to 1 by 6, means 2 into 2 raised to 1 by 6 I am getting, means I am finally getting 2 raised to 7 by 6. So, the minimum value of this function I am getting 2 raised to 7 by 6. So, A option would be absolutely correct. Now, just look at the maximum value of g of x. As we got after derivative only one point of, where derivative we are getting 0. Therefore, I would say that I am getting only one point of the minima. But what about maxima? Because this function is defined on the domain 0 to 1 only. Therefore, let us calculate its value when x equal to 0 and when x equal to 1. So, g of 0 we get how much? If I put here x equal to 0, I will get this as a 1 and 2 raised to 1 by 3, and g of 1 also I will get what? 1 plus 2 raised to 1 by 3. So, definitely these values are larger than this 2 raised to 7 by 6. So, I am getting maximum values at the extreme points of the domain, and those are what? 1 plus 2 raised to 1 by 3. So, come back and see whether this option is correct or not. The maximum value of g of x is 1 plus 2 raised to 1 by 3, that is absolutely correct, and g of x attains its maximum at more than 1 point, that is also correct, because we are getting maximum value at the extreme points of the domain at 0 and 1. 0 and 1 are actually included in the domain, therefore, at this point we are getting maximum value, those we can include definitely. So, these three options A, B, C are correct. What about last option, the function g of x attains its minimum at more than 1 point? No, we are getting minimum only at 1 point, therefore, only first three options A, B, C will be correct to this question. Well, have a look at this question number 11. Let z conjugate denote the complex conjugate of a complex number z. If z is non-zero complex number for which both real and imaginary parts of z conjugate square plus 1 by z square are integers. Let z is suppose r e raised to I theta, then z conjugate square plus 1 by z square can be written as r square plus 1 by r square e raised to I 2 theta minus I 2 theta, in fact, because z conjugate will be e raised to minus I theta and its square will be e raised to minus I 2 theta, and in the 1 by z square also you will get e raised to minus I 2 theta. What they are saying is that whatever complex number we are calculating, it has both its parts like real parts and imaginary parts are integers. Then what should be the value of mod z? Means value of r we should get is the question. So, these are the options given here, and out of this which option is correct we need to check. Okay. So, this is our complex number which in a Euler form will be something like this. So, its real part and imaginary part, suppose if you calculate, then its real part will be r square plus 1 by r square cos of 2 theta, and imaginary part will be definitely r square plus 1 by r square minus of sine 2 theta. But they are saying that these both the parts are integers, means let this is m and this is n, both are integers. Now, suppose if we square and add this, because here the coefficient of cos and this sine are same, r square plus 1 by r square. If I take a square and add, then definitely I will get what? I will get something like this. I will get r square plus 1 by r square bracket square will be equal to m square plus n square. So, this m square plus n square is actually sum of the squares of the integers. So, definitely I should get r square plus 1 by r square as an integer. Also that integer should be sum of the squares of two integers. Now, suppose if I want to check for A option. So, in A option they have given r is equal to 43 plus 3 into 205 divided by 2 bracket raised to 1 by 4. So, if I take r square, I will come to know that I will be getting here 1 by 2 means square root of this number 43 plus 3 into root of 205 divided by 2. If I multiply here numerator and denominator by 2 and adjust, I will come to know that this is nothing but root 45 plus root 41 divided by 2. So, once we get r square, we can very easily calculate 1 by r square, and that will be root 45 minus root 41 divided by 2. So, if you add r square plus 1 by r square, you will get root of 45. We need what? We need r square plus 1 by r square should be integer and should be sum of the squares of two integers. So, its square if I calculate, I will be getting 45, and 45 is actually square of, that can be written as 6 square plus 3 square. So, it is satisfying our condition, therefore, A option is correct. If you just check for B option, like here in a B option we have been given 7 plus root 33 divided by 4, 1 by 4 power is r. So, r square will be 7 plus root 33 divided by 4 raised to 1 by 2, square root of this. So, if I take now again multiply numerator and denominator by 2, I will get here 8 and here I will get 14, and if I just add this, I will come to know that that is root 13 root 11 plus root 3 divided by 2 root 2, and 1 by r square I will get root 11 minus root 3 divided by 2 root 2. So, r square plus 1 by r square will be getting root 11 by root 2. So, square of r square plus 1 by r square, you may get 11 by 2, and now it is not integer. So, in a similar fashion, if you just check for B, C and D options, you will come to know that these three will not give you integer or sum of the squares of the integers. Only A option will give you, and therefore, A option would be correct to this question. Okay. Well, students, have a look at this question number 12 here. Let G be the circle of radius capital R, which is greater than 0, and G1, G2, G3 n be n circles of equal radius small r. Suppose each of this n circle G1, G2, G3 touches the circle G externally, means the inner circle here is capital G and all these circles are G1, G2, G3 like. So, all these outer circles are touching this inner circle capital G, and the outer circles are also touching each other. Also, for I equal to 1, 2, 3 up to n minus 1, the circle Gi touches Gi plus 1, means every circle touches its next circle, and the last circle Gn also touches G1, means they are in a cyclic way touching each other one after the other. Okay. Then which of the following statement is true? So, we have predicted the diagram, and this is a diagram for this question, and from this diagram we will see which of the following options will be correct. So, definitely the angle made by any two circles centers at the center of capital G, like for the smaller circles, for these outer circles, if their centers, if I join with the inner circle center, and this angle will be, suppose these are n circles, then definitely this angle 2 pi total angle at this center of the bigger circle will be divided into n parts. So, this angle will be 2 pi by n, and definitely this distance is capital R, which is the radius of this inner circle, and this will be r. And suppose if I draw from here like this perpendicular, then definitely it will be a midpoint of these two circles intersection. So, here I will get a right angle triangle. So, in that right angle triangle, I can say that here the angle will be now pi by n. So, in this right angle triangle, if I calculate sine of pi by n, I will get sine of pi by n as opposite side, that is r, divided by this hypotenuse, that is capital R plus small r. So definitely I am getting an equation like this, r equal to small r equal to capital R plus small r into sine of pi by n. Okay. So now for different values of n, let us check which options are correct. So for A option, if n is equal to 4, then this r plus r value, which we just calculated here, r plus r value, or r plus r value, how much I will get? R plus r value, I will get small r into cosec of pi by n. Am I right? Because if the sine of pi by n, if I divide here, I will get small r times cosec of pi by n. So if you put r value, n value here as 4 for the first option, you will get something like this, r plus r equal to root 2 r. So you will be definitely getting here capital R equal to root 2 minus 1 small r. But the first option is saying that when n is equal to 4, you should get small r times root of 2 minus 1 should be less than r, but we are getting equal to, therefore I would say that A option is wrong to this question. Now if you put n equal to 5, let us see what we get. If I put here n equal to 5, so I would get, when n equal to 5, I will get this capital R plus small r by r, which is equal to cosec of pi by n, means definitely here I will get cosec of pi by 5, but cosec of pi by 5 is already lesser than cosec of pi by 6. So whatever capital R plus small r value, I will get less than 2r, because cosec of pi by 6 is 2, so that 2 multiplied with this r, I will get this 2r, which should be greater than this r plus r. So solving, we get small r is greater than r, but B option is saying that small r is smaller than capital R, so B option is also false. Now just put this value n equal to 8 in this equation, like suppose if you put here n equal to 8, then capital R plus small r divided by this small r, you will get cosec of pi by 8. So you will get capital R plus small r by small r is equal to cosec of pi by 8. Cosec of pi by 8 is already greater than cosec of pi by 4, that we know. Therefore in place of cosec of pi by 4, suppose if I put root 2, then this r into root 2 must be lesser than this numerator capital R plus small r. So definitely you will get here r is greater than root 2 minus small r. So is it given in the C option? Yeah, r is greater, capital R is greater than root 2 minus 1 small r. So C option would be correct. And lastly, when n is equal to 12, again put this value n equal to 12 in this. So you will get here pi by 12. So just come back and see, you are getting here cosec of pi by 12, and capital R plus small r divided by r will be equal to cosec of pi by 12. We very well know the value of cosec of pi by 12, because pi by 12 is how much? It is 15 degrees. So sine of 15 degrees value we know, that is root 3 minus 1 divided by 2 root 2. So cosec of pi by 3, that we can calculate easily, that will get root 2 root 3 plus 1. So capital R plus small r value we will be getting root 2 into root 3 plus 1, and this r get multiplied with this value, we get this. So if you just look at this D option, it is saying that when n is equal to 12, you should get root 2 times root 3 plus 1 r should be greater than 4. But what exactly you are getting here after putting this value? You are getting r plus r value, capital R plus small r divided by r is equal to root 2 times root 3 plus 1 into r you are getting. So if you take this r on the right side, you will get capital R is equal to root 2 plus root 3, sorry, root 2 into root 3 plus 1 minus 1 into r. So r value I am getting this much. So if I just delete this minus 1, then definitely the value of r I will be getting will be lesser than this value, because if I am subtracting this minus term from here, then whatever value I am get for this expression, that will be greater than capital R. So this expression value will be greater than capital R. So D option here will also be correct. So for this question, C and D both options will be correct. Well student, have a look at this question. The question is, let I, J, K be 3 unit vectors along the 3 positive coordinate axis. Let A bar is 3i plus j minus k, B bar is I plus B2 plus B3k, and C bar is C1i plus C2j plus C3k. where B2, B3, C1, C2, C3 are real numbers. B2, B3 product is positive, they are given, and A dot B equal to 0 they have given. They have even given this matrix form equation, and we just need to check which of the following options are correct. Very first, suppose if I take their dot product of A and B as 0, I will get dot product of these two vectors, the 3 plus B2, 3 plus B2 minus B3 equal to 0. Solving, I get B3 minus B2 equal to 0. Squaring this equation, because I am squaring this because one of the equation says mod B, and mod B will have B2 square plus B3 square plus 1 square. So, if I square, I will get B3 square and B2 square, and then I will get B3 square plus B2 square plus 2 times B2 or minus 2 times B2 B3, I will get B2 B3, and which will be equal to definitely well, students, just have a look at this question number 13. Question number 13 is I cap, j cap, k cap are unit vectors, and 3 vectors a bar, b bar, c1 are given like this: 3, 1, minus 1, 1, b2 and b3 are the coefficients of I, j, k respectively, and here for c bar, c1, c2, c3 are the coefficients. They have even given that b2 into b3 is positive, product of b2 and b3 is positive, and a dot b is 0. This matrix form equation is also given, and we need to check which of the following options are correct. So, what I will do, I will just start with this a dot b equal to 0. So, a dot b equal to 0. So, here a is 3i plus j plus k minus k, and b bar is 1i plus b2j plus b3k. So, if I take their dot product, I will get 3 plus b2 minus b3 equal to 0. So, solving, I will get b3 minus b2 equal to 3. So, if I square this, why I am squaring? Because mod b will have b2 square and b3 square, because b bar is 1i, b2, b3. Therefore, if I want to calculate its mod, then definitely I need to take its square. So, this will give me b3 square plus b2 square and minus 2 b2 b3, which is equal to 3 square, that is 9. So, I will get here b2 square plus b3 square, which is equal to 9 plus 2 b2 b3. But they have given us that b2 b3 is positive, means b2 square plus b3 square will be 9 plus some positive, means that will be definitely greater than 9, isn't it? So, if I add 1 on both the sides, I can surely prove that 1 plus b2 square plus b3 square will be greater than 10. So, if I take its square root, then I am proving here that mod b is greater than root 10. So, C option would be definitely correct. Now, just look at this equation in terms of matrix. If I solve this equation, I will get minus C3 B2 and C2 B3. So, minus C3 B2 and what? C2 B3. C2 B3 will be equal to this 3 minus C1. Then C3 minus C1 B3. C3 minus C1 B3 will be equal to definitely this 1 minus C2. Okay. Then finally minus C2 and then C1 B2. So, minus C2 minus C1 B2 minus C2 minus plus C1 B2, you will get equal to this minus 1 minus C3. So, minus 1 minus C3 you will get. If you just look at this coefficient B2 C3 and C2 B3. So, if you just take a cross product of B and C, you will come to know that B cross C will involve B2 C3 and C2 B3 and their subtraction. And even if I just check this I coefficient 1 and here is C3, 1 C3 minus B3 C1, that also I will get. So, C3 minus B3 C1 also I will get, yeah, 1 C3 minus B3 C1 also I will get. So, these are nothing but coefficients of ijk of the B bar cross C bar. So, what I will do, if I multiply these 3 equations by ijk, here with I, on right side also with I, and this with j, and this also with j, and this with k cap and this also with k cap, I can very easily prove that this is nothing but b bar cross c bar, and then this will turn out to be c bar minus a bar. In fact, this is now a bar minus c bar because 3i 1j minus 1k is our a bar. So, if you just add this later on, you may get a bar minus c bar, but this is not actually equal to b bar cross c bar, but you will get here c bar cross b bar. So, I have multiplied by minus and I can prove that I will get this equation. So, as I got this equation, which is a vector form equation, this will help me a lot to get other results. So, if I take dot product with b bar suppose, so I will get this b bar dot b bar cross c bar. To this equation I am taking a dot product on both the sides with b bar. So, I will get a box product of bbc on the left side, so that will be definitely 0, and on the right side I will get b dot c minus a dot b. But in question they have already given that a dot b is 0. Just look here, a dot b is 0. So, you are getting this as 0, means definitely b dot c also you will get 0. Is there option saying b dot c is 0? Yes. So, b option will also be correct. Now, to this first equation, suppose if we take a dot product now not with b bar, but we will take a dot with c bar, dot product if we take with c bar, then again I will get a box product, cbc box product I will get on the left side, and that will be 0, and on the right side I will get mod c square minus a dot c. So, I can say that a dot c is mod c square, but definitely c bar has some coefficient c1, c2, c3 and c bar is non-zero vector. Therefore, definitely I would say that a dot c is mod c square, means it is not equal to 0. So, a option is wrong, it is saying that it should be 0, but a dot c I am getting how much? Mod c square. So, definitely that cannot be 0. Now, we have to just check this mod c value. To check this mod c value, what I will do? I will just square this equation. So, this equation is b bar cross c bar equal to c bar minus a bar. So, squaring I will get mod b square mod c square, and definitely here I will get mod b mod c sin theta, but sin theta will be sin 90 because these two vectors are perpendicular, and on the right side I will get mod c square and plus mod a square minus 2 times a dot c. But a dot c actually we got mod c square. So, if I put here that mod c square value, I will get here mod a square minus mod c square, and here mod b square mod c square. If I further solve, I will get mod c square equal to mod a square divided by 1 plus mod b square. But mod a square value we already know because the coefficients of a are 3, 1, 1. So, I will get here 11 as mod a square, and in a denominator we have 1 plus mod b square. So, we are getting here that the right side is always lesser than 11, means mod c square is always less than 11. So, mod c will be definitely lesser than root of 11. So, definitely I would say that D option is also correct to this question. Okay. Well, now have a look at this question number 14. Question number 14 states that x is a real number. Let function y of x is a solution of differential equation dy by dx plus 12y equal to cos of pi by 12x, and y of 0 is equal to 0. Then which of the following options are correct? We need to check. So, the differential equation given is dy by dx is equal to 12y, sorry, dy by dx plus 12y is equal to cos of pi by 12x. So, this is definitely LD, linear differential equation it is. So, this will act as a Q, sorry, this will act as a P. Well, now have a look at this question number 14. Question number 14 is saying that x is a real number and the function y of x be solution of differential equation dy by dx plus 12y equal to cos of pi by 12x. So, this is definitely a linear differential equation where p is 12 and q is cos of pi by 12x. So, if you solve this linear differential equation, integrating factor you will get something like this, e raised to integration of 12 dx means e raised to 12x you get. Solving this differential equation, you may get y into integrating factor means y into e raised to 12x is equal to integration of q into means cos of pi by 12x into integrating factor, that is e raised to 12x dx. Now, you can use this formula of e raised to ax e raised to ax into cos of bx plus c formula to solve this integral, and that is definitely e raised to ax by a square plus b square, and in bracket we have a cos of bx plus b sin of bx. So, if you use this formula, definitely you can integrate right side, and solving this you may get y into e raised to 12x is equal to e raised to 12x divided by a square means 12 square plus b square which is pi by 12 square, a cos of means 12 cos of pi by 12x plus b will be definitely pi by 12 sin of pi by 12x and plus c. This is what you will get. But they are saying that y of 0 is 0, means when we put x equal to 0, you should get y value as 0. So, when we put x equal to 0, e raised to 12x will become definitely 1, and if we just solve this, the c value we should get to satisfy y of 0 equal to 0. This c value you should get, because this will go definitely 1 and here you will get 12. So, should get it as minus 12 by 12 square plus pi by 12 square. So, let us see finally what the function we are getting. So, function we are getting as y equal to e raised to 12x, sorry, y into e raised to 12x, definitely y into e raised to 12x is equal to e raised to 12x by 12 square plus pi by 12 square, then 12 cos of pi by 12x plus pi by 12 sin of pi by 12x, and then minus c value we got minus 12 by 12 square plus pi by 12 square. If we divide the whole of the equation by e raised to 12x, I will get y equal to 1 divided by 12 square plus pi by 12 whole square, and here in a bracket I will get 12 cos of pi by 12x plus pi by 12 sin of pi by 12x, and here minus 12 e raised to minus 12x divided by 12 square plus pi by 12 square. This is what I will get. Well, now if you just look at the options, what they are saying, option A is saying that it should be increasing function, option B is saying that it should be decreasing function, option C is saying there exists a real number beta such that the line y equal to beta intersect the curve y equal to x at infinitely many points, and y of x is periodic function. Definitely we can take derivative and prove that it is going derivative is coming positive and negative sometimes. So, it will be definitely increasing as well as decreasing. So, we can't say here that A and B options are correct, because derivative we get positive and negative. But one more easy way I feel is that when x is tending to suppose infinity, then definitely this power will go minus infinite and this will tend to 0. But this, if you purely see that this is a sin x plus b cos x term with some coefficient, so definitely it will go positive and negative, because that will be reduced to trigonometric function. We can just convert this into just one sin term or a cos term, and definitely we can say that that will have some positive and negative value. So, it will be definitely a many one function, and as this will tend to 0 when x are very large, then definitely it will cross x axis many times. So, I would say that from here only we can say that this is oscillatory, therefore, we can't say that it is increasing or decreasing, and definitely we can say that as x axis itself will cut many times, because when x is very large, then definitely this curve will intersect this x axis many times. So, definitely some parallel line to the x like y equal to beta will cut this graph infinitely many times. So, C option would be correct. Y of x is a periodic function, that we can't say because it has a periodic form like e raised to minus 12x, so it cannot be periodic. So, D option is wrong. So, only C option would be correct to this question. Okay. Just look at this question number 15. Consider 4 boxes where each box contains 3 red ball and 2 blue balls. Like this is the box 1, this is box 2, this is box 3 and this is suppose box 4. Assume that all 20 balls are distinct, means all these balls are distinct here. None of the ball is similar to other ball. In how many different ways can 10 balls be chosen from these 4 boxes so that from each box at least 1 red ball and 1 blue ball are chosen? See, we need to choose 10 balls from these all 20 balls, and we need to choose at least 1 red and 1 blue from each box, means definitely from each box we need to select 2 balls, at least 1 red and 1 blue. But if we choose 1 red and 1 blue from each box, then definitely we are choosing 8 balls, but we need to choose total 10 balls, means 2 more balls we need to choose from remaining balls from any of the boxes. So, if I choose like 2 from first box or second box, then I will get like first case as I am choosing from one of the box as 4 balls, then from other 3 boxes I am choosing 2, 2, 2. So, this is the one case I am getting. So, from one of the box I am choosing how many balls? 4 balls, and for remaining 3 boxes I am choosing 2, 2 balls. So, definitely these 2, 2 balls will be red plus blue, every 2 ball. But these 4 balls which I am choosing from one of the box, how I can solve this case for? I mean, if I am choosing 4 balls from one of the box, we have actually 4 boxes. So, first choose from where you are choosing the 4 balls. So, that can be done in 4C1 ways. So, you have chosen the box from where you are going to choose 4 balls, and after that, that 4 ball can be chosen like, that 4 ball can be chosen like, suppose you are choosing from this box 1 4 balls. So, that can be chosen like from 3 balls you are choosing from 3 red ball you are choosing suppose 2 red balls, and from remaining 2 blue ball you are choosing 2 blue balls. So, you are actually chosen here 4 balls, but that is not the only case. You can even select all the 3 red balls and then 1 blue ball. So, these 4 balls from one of the box you can choose like this. Then from remaining 3 boxes you have to choose 1 red and 1 blue. That can be done in what ways? 3C1, like from 3 red you can choose 1 red in 3C1, and from 2 blue you can choose 1 blue in 2C1 ways. So, that will happen for every other box 3 times, therefore, I will take its cube. So, this is what is the case, and if you solve this you will get some number, and then definitely case 2 will be what? Now, suppose from the first box or some of the boxes you are choosing 3 balls, 2 of the boxes you are choosing 3 balls, and other 2 boxes you are choosing 2 balls. So, that may happen. So, very first you need to select 2 boxes from where you are choosing 3 balls. So, that can be done in 4C2 ways. You have chosen these 2 boxes from where you are choosing 3 balls. Now, these 3 balls can be chosen like this way, like we have here 3 red and 2 blue. So, we may choose 2 red from 3 red and 1 blue from 2 blue. This may be one case for choosing these 3 balls, or other case is you may choose definitely 1 red from this 3 red, but you can choose all the 2 blue from this remaining 2 blue. So, these are the 2 cases you may get for choosing 3 balls from these 2 boxes, but this will happen twice, therefore, I will take square, and these 2 balls from remaining 2 boxes can be done in definitely 3C1 and 2C1 and its square. So, just solve this. 4C2 you will get 6, and here 3C2 will be definitely 3, and this will be 2, and this 3 and 1 bracket square, and here you will get 3 into 2 square. So, you may get here something like this. So, this result for case 2 and earlier this result, if you add, you will come to know that the final answer to this question will be equal to 21816. So, the right answer to this question from the section 3 question number 15, you will get the right answer as 21816. I hope you understood this.
And the first we have, if M, question number 16, one matrix 5 by 2, 3 by 2, minus 3 by 2 and minus 1 by 2, then which of the following matrices is equals to M to the power 2022? Just think about here, of only one thing, only one weapon, or we can say that we have is, we need to think about this matrix. And can we write this as 5 by 2 as 1 plus 3 by 2? Yes, definitely. This is the key point for this one. Rest of the things are very easy for this question. Even you can get the answer within a minute, right? So when we can write this 5 by 2 as 1 plus 3 by 2, and here we have 3 by 2. Now here we have minus 3 by 2, and here we have minus 1 by 2, right? Now, can we write it as 1 plus 3 by 2, and this minus 1 by 2 also I just want to write in terms of the minus 3 by 2, then can we write it as minus 3 by 2, and here we have, and the next one we have minus 3 by 2 plus 1, it will become minus 1 by 2, yes, definitely. Now, can we take, here you can see 1 plus 3 by 2, we can write it as I plus 3 by 2, and here we have a one matrix in which we have 1, 1 and minus 1 and minus 1, yes, right. Here we have 1, 1 and minus 1, minus 1. I just want to assume this one as A. Now, I just want to take focus on this A, then we have, actually I want to do the square, right. So the square of this, you will get a very interesting thing, that is the null matrix, right. You will get the square of this is null matrix. Now the things are very easy, because now we can conclude about M as, because we have I plus 3 by 2 into A, and here we need to find 2022 as the power. Here we have I plus 3 by 2A, 2022, and you can open this expression as by using the binomial theorem, and we have the final one, that is what, I only plus 3033A, because after this you have what, you have A square term, you have A cube term, and you know that once A square is 0, all the terms will be 0. So that's why I just want to take the first one, that is I plus 3033A, and here we can conclude about this as identity, that is 1001 plus 3033 into A, 3033 into A, 1, 1, minus 1 and minus 1. Now we can conclude here 1 plus 3033, here we have 3034, and here we have 3033. Again, no need to solve further, you can correct the option, that is what, 3034, 3033, 3034, 3033, we have only first option is the correct one. Hope it is clear to everyone, right? It's quite easy, very easy question in paper 2. Now the next question we have, this is the one interesting one, once when we read properly. Box 1 contains 8 red, 3 blue and 5 green balls. Now, box 2 contain 24 red, 9 blue and 15 green. Actually, in short, we have the one data and we have the 4 boxes. Now, a ball is chosen randomly from the box 1. When this ball is B and this B is red, let's say the chosen ball is red, then we have to move for box 2 to pick a green ball, right? Once when B is red, then a ball is chosen randomly from box 2, only box 2, right? Now, if B is blue, alright, if B is blue, then what happened? Then a ball chosen from box 3, right? If B is green, then the ball chosen randomly from box 4, right? So once we have the 4 boxes, let's say we have the red ball, we choose out from the box 1, then we have to go for box 2 for the next round. If the chosen ball is red, we have to go for second box. If the chosen ball is blue, we have to go for third one. If the chosen ball is next one, we have green, then we have to go for fourth box. Are you getting my point? Right. Now, the conditional probability of the event, one of the chosen ball, we need to find the conditional. Chosen ball is white. Given that the event, at least one of the chosen ball is green. Now, see here, when we have B, let's say this is the B, in which we have given that is at least one of the chosen ball. Actually they are asking about the conditionals, so in short I have in mind that is we need to find P A by B, right, and the denominator B we can assume at least one of the chosen ball is green. So this is the data, at least one of the chosen ball is green, right, and A we have what, one of the chosen ball is white, both are the given, right, one of the chosen ball is white. Now we need to find A by B. So first we need to think about this, how we can find the at least one of the chosen ball is green, right. So see here, first I just want to take about this A intersection B, and here we have P of B. We need to find this one. So A intersection B, we have only a one thing in which green and white is the combo we have, right, and the green and white we have only the one case. Let's say we have box 1, when we picked, there's a green ball, and then we have a one case in which we have the white balls. So in short we have the intersection only one in which we have A intersection B only, A intersection B, which is green and white, right, or in a proper order you can write it as white green for better understanding, not at all. Now what about B? For B, let's say when we choose red ball from box 1, then we have to go for second box to choose green ball, right. So red and green we can make a combo, that is red and green, right. Once we choose red, we have to go for second box to choose green. Now what about the second one? Next, let's say we pick or choose blue ball, then we have to go for third box to pick green. So blue and the green we have the next combo, and so on. We can say the green. Okay, what happened when we choose green? So here we have a one combination, that is because it is given that at least one ball is green, so we can pick the green and the next fourth box green, orange and white, right. So green, orange and green, white we can take. Are you getting my point? Yes. Now we have 5 possibility for B, and it's time to conclude the answer for this one. P of A intersection B upon P of B we can find, because this is the conditional probability A by B that we have, that is what, intersection B we have white and green, and the probability to pick the white ball, that is what, where is white ball? White ball, here it is, that is what, 6 upon 10, 16, 6, that is 32, right, 6 by 32 into 6 by 32, and we have next one, that is 5 by 16, and same thing we can do for this one. What would be the probability for red ball? We have the red ball here 8, and 8 by 8 and 16, so 8 by 16, right, would be the probability. And the same thing we can do, what would be the probability for green? Green we have to go for the second box if we choose red, so we have the 15 green, so 15 upon 24 plus and 15, it would be a 48, right, so 15 by 48. Next, blue and green. So once we pick blue, so we have the probability, that is 3 upon 16, and the probability for green. So once we pick blue, we have to go for third box, and the probability to pick the green, that is 12 upon 12, 3 and 4, okay, 12 upon 16. And the same thing we can do for the next one, that is for green. And the green, because we have the probability for green, that is what, 5 upon 16, right. And what do you think about this? What do you think about this? Actually we already have the green ball, so there is no need to take the further action. So in short we have the 100% probability because we have the green ball, right. So that's why we have the data. Now when you solve this, then you will get the answer, that is 5 by 52, right. And the 5 by 52, where it is? 5 by 52, here it is. Option C is the correct one for this question. Hope it is clear to everyone. Now come to the next one. In the next question we have, for positive integer and define f of n, we have this one. Actually when I read this question further, when we see here, we already did a lot of question in p by q. Here we have in which we have limit n tends to infinitive f of n, and this is limit as a sum, right? Yes. Now it's time to improve the data. How we can write this as 16 plus 5n minus 3n square? Actually I just want to write it as 16, and once when you see here 16, here we have 32, here we have the 48 and so on, right? So in short we can write here 16r, right? Now the next one, here we have 5n, here we have, and here we have minus 3n. When you think about this 5, 1 and minus 3, this is the AP, right? Yes, definitely here we have the common difference, that is what, minus 4, and when we write the nth term, then we have, okay, 9 minus 4r is the 9th term, right? And here we have the n. Fine. Now the same thing we can do for the last one. We have the minus 3n square, minus 3n square, minus 3n square and so on, right? So I think we have no worry about this. Now actually I just write the general term, and in the denominator we have what, 4n plus 3n square. So can we write it as 4n, 8n, 12n? So here we have 4rn, right? And the 3n square again the same one, 3n square. Now here we can conclude about this r should be is equals to 1 to n, right? And here we have limit n tends to infinitive. Now I just want to write it as 16r plus this 9n and then minus 4rn. Then can we write 16r plus 9n? Yes, definitely 16r plus 9n I just want to write. And the next one we have minus 4rn minus 3n square. So 4rn plus 3n square, while taking the negative sign as a common, and in the denominator we have the same thing, that is 4rn plus 3n square, right? Again the same thing that we have, that is summation r is equals to 1 to n, and we have to move limit n tends to infinitive, right? Now here one more thing data that we have is n plus n plus. Now you can see here we have this term only. Now when we are going to further solve this one, minus 4rn plus 3n square upon 4rn plus 3n square, definitely it would be cancelled while we are going to take this by this, right? So then we have minus 1 only, and minus 1 minus 1 minus 1 we have n times, so then we have minus n only. Are you getting my point? So here we have n plus this thing, we have 16r plus 9n, and here we have 4rn plus 3n square minus we have n. How? Because 1 1 1 we have n times. Now it would be cancelled. Rest of the things we have same, summation r is equals to 1 to n, limit n tends to infinitive, right? Now here we can convert, because I just want to use the limit as a sum concept, so we can convert this thing. We can write while taking the common, and I want to design it as r by n plus 9 1 by n only, and here we have the 1 by n common, and in the denominator we have what? And in the denominator we have 4 again r by n while taking the n square as a common, and here we have 3 only. 4 r by n plus 3, all the things are correct as this one. Okay, here we have not a 1 by n only because we took 1 by n as a common. Summation r is equals to 1 to n, and limit n tends to infinitive. Fine. Now can we write it as this r by n? Now we can, as usual, we can replace the terms as 1 by n 0 to 1, and this 16 r by n we can write r by n as 16x, right? R by n in place of r by n we can write here x plus 9, and in the denominator we have 4x plus 3. Similarly we can now open this one as 0 to 1, here we have 1 here, right. 0 to 1 we can write it as, yes, 4 minus and then 4x plus 3, so 16x plus 12. Okay, so we need to take the 9, so we can take here 3. And now we can apply the integration, and here we have the 4x only, yes, and here we have, because of this linear, here we have 3 ln 4x plus 3, and here we have 0 to 1. Now upper limit minus lower limit as usual we have, then we have here only 4 minus 3 ln, here 4 plus 3 7, when we substitute here 0, then here we have the 3 only, so ln 7 minus 3, then we can write 7 by 3. And now look into the option, 4 minus 3 ln 7 by 3, where it is 4 minus, alright, 3 by 4 we have, is there any mistake? 3 by 4, yes, here 3 by 4, right, integration of ln 4x plus 3, we have, okay, 1 upon x, the integration of this one, we have ln 4x plus 3 upon 4. So here we have 4 minus 3 by 4 ln 7 by 3, where it is 4 minus 3 by 4 ln 7 by 3, option B is the correct one. Hope it is clear to everyone, right. So, and this is the last question of the paper 2. Alright, have a good luck, meet you soon, thank you.